Hello, everyone. Welcome back to the Microcontroller Application Technology course. Today we are going to learn about controlling a single digital tube to display different numbers using dual keys. We will delve into the following 4 aspects in our learning process. Through the design and implementation of this task, you will master the connection of an independent keyboard circuit, the writing of the independent keyboard debounce program, the writing of the independent keyboard key press judgment program, and reinforce the application of displaying numbers on a microcontroller digital tube. In our daily production and life, we often use keys. For example, using keys to select washing machine programs or to increase the volume on a TV. Today, our task is to use 2 keys to control a single digital tube to display different characters. When K1 is pressed, the digital tube displays 6. When K2 is pressed, the digital tube displays 9. First, let's take a look at how an independent key is connected. Connect the key to ground, then individually connect it to an I/O port, and connect pull-up resistors R2 and R3. The process of detecting a closed key is as follows. Apply a high level to the port, continuously check the input status of the port line. When the input status is high, it means the key is not pressed. When the input status is low, it means the key is pressed. Next, let's address the issue of key switch bouncing. The structure of a key is a mechanical switch structure. When this type of mechanical key is pressed or released, due to the influence of mechanical elasticity, there is usually a certain amount of voltage bouncing for a period of time. This bouncing process is related to the mechanical characteristics of the switch and typically lasts 5 to 10 milliseconds. This bouncing is imperceivable to humans but can be sensed by a microcontroller, causing incorrect judgments and leading to the CPU performing multiple operations on a suspected key press. This scenario is unacceptable. To overcome false detections caused by mechanical bounce of key contacts, debounce measures must be taken. This involves the microcontroller delaying the detection of a low-level signal by 10 milliseconds after receiving it. If the signal is still low after the delay, it confirms that the key has indeed been pressed, effectively bypassing the bouncing time when the key was pressed. As for detecting the release of the key, a 10 millisecond delay is applied after the key is released to eliminate the bouncing of the trailing edge, and then further processing occurs. In general, it's not necessary to process the bouncing of the trailing edge of the key release, as it generally meets requirements. How does the microcontroller determine and execute actions when a key is pressed? This involves keyboard programming. Keyboard programming aims to enable the microcontroller to accurately identify which key is pressed and execute the corresponding processing as needed. Let's summarize some rules of independent keyboard programming. 1. Determining if any key is pressed on the microcontroller, taking into account the effects of debouncing through delays. 2. Once it's confirmed that a key is pressed, it needs to ascertain if only one key is pressed. 3. Identify which key is pressed and obtain the keyboard code for that key. 4. Based on different keyboard codes, jump to the corresponding processing program. Next, let's decipher this program. The program mainly consists of the main function, delay function, and key function. The first line defines special registers for the 51 microcontroller, then defines P2.7 pin as K1 and P2.6 pin as K2. The delay function uses a parameterized delay function. In the key function, if K1 equals 0, it means K1 has been pressed. After a delay, it checks if K1 is still 0. If it is, then K1 has indeed been pressed, and the hexadecimal code 0x7D46 is sent to P0 port.
Similarly,
K2 is checked. If pressed, the hexadecimal code 0x6F49 is sent to the P0 port. In the main function, 0x00 is sent to the P0 port initially to ensure the digital tube doesn't display anything. Then the key function is called. After the program design is completed, the simulation is carried out. Initially, in Produce, the circuit is connected according to the circuit diagram. Then the program is written in Keil software, compiled to get a HEX file, which is then loaded into the microcontroller chip in Produce for simulation. Press any key and observe if the digital tube displays correctly. In this task, we primarily learned about using an independent keyboard, the debounce method for keys, and implementing the control of a single digital tube display with two keys using if-else statements. Finally, here are a few homework exercises for you to reinforce the knowledge learned today and deepen your understanding. Please make sure to complete them diligently. That concludes this lesson. See you in the next class.